You need to understand them conceptually, and you need to understand how to implement them in your object-oriented programming. Okay, first of all, let's remind ourselves, what are the difference between these three types of relationships? Any idea what's the difference between association, aggregation, and composition?
They're all associations, but like different levels of dependence on each other.
Okay, very good. So every relationship is an association. So association is a very generic name or generic term used to refer to association relationship between classes. Now, when do we say that an association is an aggregation?
When the relationship between classes are whole and apart.
Okay, very good. Very good, yes. So when the association represents a whole and a part relationship, we have some whole class and we have a part class. If the relationship is a whole and a part, then we can upgrade the association to an aggregation. Okay. So in an aggregation, the part can have its own life cycle, can have its own life. So even if the whole is destroyed, the part can still live on. Okay. Now, if we compare aggregation with composition, in the case of composition, it is still an aggregation. We have a whole and a part. But if the whole is destroyed, also the part will be destroyed. It cannot exist in a meaningful way on its own. Okay, so those are the concepts. But as I recommend for you before, every concept you should try to associate it with an example. So let's try and give some example for each of those types of relationships that can exist between classes. So the first type, any example?
Association.
Of association, yes, please. Simple example. By the way, when you try to put some example in your mind regarding some concept, try to pick a simple example.
Okay, like Qatar University. Qatar University consists of faculty, Qatar University members.
Okay.
Consists of faculty, administration, and the students.
Okay.
And the students are part of the students do have their own activities.
Okay, so here what you're referring to some other relationship that is not covered here, which is basically the inheritance relationship. The inheritance relationship, which is the fourth type of relationship, where, for example, here you have QU member, which is a general class, and as a subclasses, we might have student, we might have faculty, and we might have admin. Yeah? Okay, so this relationship is none of these three. This is a different type of relationship, which is called inheritance relationship. And this inheritance relationship, the way we read it is we read it like this, is a relationship. So student is a QU member, and faculty is a QU member, and an admin is a QU member, okay? This is another special type of relationship we will be covering in more details later on. We'll spend maybe 1 week just going through inheritance and how the inheritance is implemented. But this is definitely not an example of association. It is an association, but special type of association, which is inheritance, which is not the focus of this session. Okay. Now, association. Let's just give you a simple example. For example, let's say account and customer. Definitely, there is an association between the two. So, for example, an account can have one customer and a customer can have multiple accounts, for example, okay? And this is basically an association. It's not a composition because the customer is not composed of or the account is not part of the customer, and vice versa. Okay, this is just a simple association. Now, what about an aggregation? Any example?
The car.
This is a good example, yes. Very simple example. The car and engine. Of course, there is an association between the two, but it's a special form of association. In fact, the car is a whole and the engine is just a part. So this is definitely an aggregation. So what I'll do, I put here using, by the way, this is using UML, Unified Modeling Language symbols. I put the diamond on the whole on the class that is a whole, and then I put the association here. And I can put also what is known as multiplicity. I can say car has one engine and an engine belongs to one car. Okay. Now, once I establish that this is an aggregation, I can ask myself, can the part has a life on its own? Can it exist in a meaningful way without the whole?
Yes.
Yes, because the car can be gone, but the engine can still have a life, continue its life cycle, and it can be sold or used in another car by itself. Okay, but composition is an example. The best example for composition I can think of is building. Is a building and a room. Okay, is a building and a room. So definitely the building is a whole and the room is a part, and the room belongs to one building, and a building can have multiple rooms. But what happened? Can a room has a life? Can the room has a life on its own? No. So if the building is destroyed, what happened to the room? Also destroyed. So this is a strong form of aggregation. So in this case, what we will do, we will go to this diamond and we fill it. So this is what UML language tells us. This is a language. When somebody looks at this diagram I'm writing here, they will know how to read it. So this is composition. The relationship between building and the room is a composition. The building is the whole, and the room is the part. But the part cannot have a life cycle on its own. Its life cycle or its life is totally related with the whole, with the building. If the building is destroyed, the room is destroyed. But in the car example, it is a whole part relationship. But we see many times there's a car gets big accidents, maybe on the side, in the back, is no longer drivable. But the engine is still good. We will maybe throw the car, but we will not throw the engine. Yeah? The engine will still live on and can have a life on its own. So that's basically the idea. And the first one is just we keep it as an association because there is no whole part relationship here. It's just a simple association. Yes? Now the final one is inheritance, which is even a very, very special case of association. And this is the subclasses must be related to the superclass using this is a relationship. And the symbol we use to express this is a triangle, a small triangle. This is not a diamond. Okay, this is who told us these symbols that we're using here? This language, the UML modeling language. Is clear the relationship between classes are clear? At least if you make it an association, this is good enough. If you can make it more precise and upgrade it to aggregation or composition, that will be even much better. Okay, so this way you can understand the relationship in a more precise way. But the inheritance is a special case. Please don't confuse inheritance with any of these other three. It's a special case where the subclasses are really the same as the superclass. They just happen to have extra attributes and extra methods specific to them. Okay? That's it. This is the concept. But let's see now how we can make this concept. How does it reflect when we are doing our object-oriented programming? How do we establish association between classes in our program. That's what I want to focus on in this session. So let's start with something we're already familiar with, something we did together before, which is our account class. So if you recall, in the account class, we had some attributes. What were these attributes? We had the ID int, we had the name of the customer, which is a string. We had the type, which is also a string, and we also had the balance, which was double. Okay. Now, this attribute, it's a little bit oversimplification, because at the time we didn't know how to put association between classes. So we put a simple solution, but now that we learned that we can have classes and we can have associations between them, it's time now to really define a proper class for customer. So the customer will have their own class. For example, what could be the attributes of the customer?
The name.
They could have their own ID first, let's say Qatari ID or passport number, some kind of ID. Let's keep it simple, keep it as integer. They will have, let's say, first name as a string, and last name also as a string. And let's just keep it simple, an email as a string. Of course, they can have much more, such as mobile, date of birth, nationality, and so many other things. But let's keep it simple for now. Is there any relationship between these two classes? Yes. So how do I represent this visually? Drawing a line. Okay. And if I wish, I can put some multiplicity here. I can say an account belongs to one customer, and a customer can have, for now, let's keep it simple, one account. Later on, we can upgrade it to say a customer can have multiple accounts. But for now, if I read it this way, this is belong. If I read it this way, this has. And the multiplicity is a one-to-one relationship. This is a one-to-one relationship. Can I upgrade this association to an aggregation? No, because there is no whole part relationship. Just a simple association. Is clear so far? So what we want to do now is we want to reflect this relationship in our code, in our implementation. How do I associate an account with a customer? How do I create an association? So I create an association by basically adding an attribute in the account class. I add an attribute of this, and the type of that attribute will be the type of the class that this account class is related to. So I will have here, the account will have a customer attribute. And what's the data type of this customer attribute? Customer. Okay. So this way, when I add this attribute, I am adding this attribute here. If I add this attribute, what will happen is this account class becomes aware of the customer class. And this way, the account will be aware of its owner. I can, if I wish, I can also do the same on the customer side. In the customer side, how do I make the customer aware of the accounts they have? By adding an attribute here. What will be the name? Account. The same name as the class, but with lowercase. And the data type is account. So this attribute, these are two attributes. This attribute allows me to implement this belongs to relationship. So the account is aware of the customer, and this attribute here allows me to implement this other side of the relationship, which is the customer has an account. It becomes clear as we develop it together. But for now, the way I establish a relationship between classes, association between classes, is, you remember, an association is associating two parties. This is the left side and the right side. So what I do, I create an attribute of the same type as the right side. On the left side, I create an attribute having the data type, the data type of that attribute is the data type of the right side. And on the right side of the relationship, I create an attribute, and the data type of the attribute is the class name of the left side. If you want to take it kind of mechanically for now, yeah, that's how I establish a relationship between the two classes. So let's do it together by extending this class that if you remember, I think now 2 weeks, time flies, since we did this class, okay? If you remember, these are the attributes, let's say ID, name, type, balance, okay? If you recall, our goal here is to enhance this class so that the customer, we have all the details of the customer, not just the name, okay? So we want to replace this name with the whole customer object. So first, before we do this, let's go ahead and create a customer class. Let's first remember, because what we're trying to do here, we have two classes. We have account and we have customer. So far, we developed the account class, but we didn't create the customer class yet. So that's the first thing we should do. So let's go ahead. I right-click here and say new class. And what's the name of the class? Customer. So once I do this, I start defining the attributes of this class. So I'll go ahead and say private int, this is the ID, and private string, this is the first name, and then the last name, and then the email. Yes? And then, of course, I can do get and set methods and also the constructor. So because you're already familiar with the concept, I will just go ahead and generate them. So I go to source, generate getters and setters, say, please go ahead and generate getters and setters for every attribute. So I have get ID, set ID, get first name, set first name, and so on. What is left now is to create the constructor. Again, I go to source, generate constructor from the fields, and then I go ahead, and this is my constructor created. Yes? Is clear? So I created the customer class. Yes, please.
First name and last name, and should not uppercase?
Either way, there are some in dictionary. Let me try my dictionary. Yes, it's fine. Either way is fine. If you want to call it this way, is fine. But also this one is also acceptable. Yeah, first name as one word, it's okay. But if you wish, you can do it the other way around. It's fine. Okay. Now, is my customer class created? Can I move on? No. Before I move on, every step I do, I have to test it to make sure it works before I move to the next step. Okay? So how do I test it? I go here, and I will go ahead and create a customer. Okay? So how do I create a customer? So here is a customer. Since we have here account Sarah, I will call it Sarah customer equals a new customer. And the ID could be 235. And the first name is Sarah, and the last name is Saleh, and the email is sarah@test.com. Yeah, is okay. Yes, that's how I create an object of type customer, and then I will just go ahead and print some details about this customer. So I'll come here and say Sarah customer.get first name plus some space plus Sarah customer.get last name. Okay, this is okay. Let me I just want to comment all of this because we don't need it. Okay, so now if everything is working, I should see here the first name and the last name display. So if I run this, this is my first name, last name of this customer display. So I'm happy the customer is working, the customer class is created and it's working. Now I can move ahead and do the other task. So the reason why I'm saying this, please test as you go. You cannot afford to just keep writing your code and hope it will work. You must test as you go. Okay? So, and otherwise, once if you have a problem later on, you won't know from where this problem is coming. So, but if you test as you go, you are building in a good base. As you move forward, you are confident what you did is working. Okay, now we have a customer class. It's now time to make this account aware of the customer. How do I make the account aware of the customer, or aware of the customer the account belongs to? So in another way to say it, how do I establish an association between account and customer? How do I establish association between these two? So what I will do here,
replace the attribute name with
so I don't need this name anymore, so I will just for now comment it out, and I will replace it in this case with an attribute. I will call it customer, attribute customer, and what's the data type of this customer? Customer. So this way, the account is aware of the customer. So this way, the account is aware of customer. Yes? Okay. Now, of course, now the whole class has problems. I need to go ahead and fix those issues. So first here, I no longer have the name. Instead of name, what the parameter will be? It will be customer. And basically, instead of using the name, I will use customer. Okay? This is clear? So when I create a new object, I specify the ID of the account, the customer the account belongs to, and then the type, whether it's saving or current. Now here I have another attribute, another constructor. I will do the same. Let me just copy this. So instead of name, I pass on a customer object, and I can put here customer equals customer. But you notice here, these three lines are exactly the same, which is not very good. It's not very healthy. We should not have duplication. How can I get rid of this duplication? I wish I can just call this function or call this constructor so it will initialize the first three attributes for me so I don't repeat these three lines. So the way I can do that, I basically delete those guys. And then I'll say this, and I pass ID, customer, and type. Yeah. So this basically refers to this constructor, and these parameters will be passed to this constructor to initialize these three attributes. So what's the advantage of doing this? To avoid repeating those three lines. Okay. So I am reusing that constructor that I defined before. So I'm reusing it. And then in here, if you notice the balance, what I do with the balance, I call the deposit, and the deposit will take that balance and add it to my balance. Is clear? Okay. There are, of course, still problems in my implementation. So you can see here I have get name, set name. I don't need these two. Instead, I will replace them with get and set account. So I don't need to type all that stuff. I just go to source, generate get and set, and then I'll do it for customer. So I'll have here get customer and set customer. Yes? Okay. There's one more here. This one is comparing two accounts, that whether these two accounts are the same or not the same. So I don't have the name anymore, but how can I get to it? by saying this dot customer dot, maybe I just compare the IDs, get ID. If the two customers account dot get customer dot get ID. I mean, two accounts will be equal if they have the same ID, they belong to the same customer, they have the same type, and they have the same balance. If this is the same, if these conditions are true, all these conditions are true, then these two accounts are equal. Otherwise, if any of these conditions is false, these two accounts will be different. Yes. Okay. Now? You see here the account now is fine. There's no red kind of cross there. Everything is okay, and we achieved what we want. We achieved now the account is aware of the customer it belongs to. Okay. How did we make the account aware of the customer it belongs to? By creating an attribute, and that attribute, the data type of that attribute is the customer class. So this way, from account, I can get to the customer details from the account. Yeah? And it is very common to name the attribute the same name as the class with first letter as lowercase. This is the most very common practice. To establish, what I did now, I established an association between account and customer. So the account is aware of the customer. And how do we make the account aware of the customer? By taking the customer and making it as an attribute of account. Is clear so far? Okay, now, application, of course, is still not happy. So we need to fix it. So initially, we used to send the name of the customer as a parameter in the constructor. How to fix this? We should instead now pass the whole customer object. Okay, so the constructor is now happy. So when I want to create an account, first I create the customer, and then I go ahead and create the account. How do I create the account? I provide 4 initialization parameters. The ID of the account, the customer to whom the account belongs, the type of account, and the balance. And then this will go ahead and construct for me an account. Yeah. Is the application now happy? No, there is still some issues. If we go down here, there is Sarah account.getName. There is no more name, but from where I can get the name? From the customer. So I have to say this.get customer, and then from customer I can say this.get, let's say, first name. Okay. Is this happy now? The application is happy? Yeah. Yes, everything is happy. Now I cannot just say move on. No, I have to test it, run it, and test it. And you can see here what I have here. I created successfully a customer. I successfully created an account and deposited some money on it, and I successfully linked the account with the customer. And this is all now working. Is clear? So if I have an account object, can I get to the customer to whom this account belongs to? Of course I can. This is what I just did here. From the account, I can get to the customer object, and then once I am in the customer object, I can call all the methods belonging to the customer object. Yes? So which side of the association I just implemented? You remember, sometimes or most of the cases, association is bidirectional. I have 2 directions. So what is the first direction? Which direction did I implement so far? The account belongs to customer. And now the account, is the account aware of the customer to whom it belongs? Yes. Now, if I am in customer, is the customer aware of the account they have? No. So far, I only established one directional relationship or one directional association. If I want to make it bidirectional, it's 2 sides. The customer is aware of the account and the account is aware of customer. How do I make the customer aware of the account?
Adding an attribute.
By creating an attribute, and the data type of that attribute is the class name of the other side of the relationship. Yeah. So that's it. Very easy. So I'll go ahead here, and there is my customer. And all I need to do here, how do I make the customer aware of the account? So I'll go ahead and say private account, data type is account, and the attribute name is account. Same name. This is very common practice. Except in here, how do I distinguish between the object and the class? The class, the first letter is uppercase, and the object, the first letter is lowercase. This is how I distinguish between the two. Okay, now this is private. How can I allow a reading and a writing to it? By providing getters and setters. I'm not going to waste time writing all that stuff. I get Eclipse to generate it for me, and it generates successfully get and set. Okay. I'm not going to put the account in the customer constructor. Why is that? I'm not going to put the account as one of the attributes of constructor, and as one of the constructor attribute, or one of the constructor parameters. I'm not going to change the constructor to put the account yet. Why this is so? Why do you think it's not a good idea? I come here and say account. Why it's not a good idea to add this attribute?
Cases where a customer have more than one account.
That's kind of one reason. But more realistic reason is that first I create the customer, and then later I create the account. Okay, so I might not have the account at the time of creating the customer. Okay, so let's just keep it simple like this. Now in the app here, after I create the customer, I create an account for it. For her, in this case, how do I make the customer aware of their account? So all I do here, this is Sarah customer, and I do set account, and I pass in Sarah account. So this way, the customer now is aware of the accounts they have. Is clear? Yes? No? Yes? Yes? Okay, so now if I am in customer, can I get to the account details? If I have a customer object at my hand, can I get to the details of the account they have? Yes. So what I can do, if I copy this, so I can see here, for example, I can say here, welcome. Okay. Here is the details of the customer. Plus, I can also get to the balance, for example. Your account balance. Your account balance is, and how do I get the account balance of the customer? Sarah customer dot get account. And from account, I have the whole object. I can access all the public methods I have in this object. In this case, get balance or get type or get whatever I wish to get. Okay. So this way, you see here, this is what really association means. The customer is aware of the account, and from customer, I can get to the account object and do whatever I wish to do with it, and vice versa. Account is aware of customer, and I can do whatever I wish to do with it. From the account, I can get to the customer object, and I can call the methods offered by the customer object. Mm-hmm. Is clear?
Can we do that up to multiple accounts, like each account calling the other account?
What do you mean?
So like multiple classes. So get this class and then get this class and then going on.
Yes, of course you can. Like, for example, let's say if in this example, let's create, although I don't want to make it complex, but let me just, super easy, create a another class called address. Yes? An address, if you know, the address has at least three things. Let's say the address, we have the street, the city, and the country. Yes? In an address, we have these three things. So what I can do here, generate these guys. Here it is. Source, generate getters and setters. Here are the getters and setters. And then I'll go ahead and generate a constructor. Okay, so here is an address. So what I can do here, in the customer, they have an address. How do I make the customer has an address? So I basically have here private address. This is the data type address, and this is the object address. Yes? Now, what I can do is I can provide some getters and setters if I wish. So here it is. If I go here, source, where is source? Oh, yes, here. Okay, so getters and setters, and here is the address. Okay, so I provide get and set address, and if I wish, I can also provide another constructor, another version of constructor that will also take the address as parameter. Okay, and to avoid repeating all of this, what I will do, this dot, and I pass to it all this stuff. It will initialize for me all the attributes except the address. Yes? Why I'm doing this? To avoid repetition. This is very critical, not to repeat, not to have redundancy or repetition in my code. And then what is left here is to set the address. Yes, it's clear? Okay, now in the app here, in the application here, what I can do before I create the customer, I can create an address. Here is the address. I can call it Sarah address or an address, whatever I wish to call it. New address. And the street could be 44 University Street. And the city is Doha, and the country is, that's it. I created the address, and now when I create Sarah's account, if I wish, if I have an address, I can add it here in the constructor. Can you see it? I can put here the address, Sarah address. Okay, so when I create an account, sorry, when I create a customer, I put the customer details plus the address object. Now in here, take a look at this. What I can do here plus, and I can tell the customer your address is plus, so Sarah account dot, how do I get to the address? From account.
To the customer first.
I need to get to the customer first. Here is the customer. And then from there, how do I get to the address? Get address. And then from there, how do I get to the street? Get street. You get the idea, yes? So, yes, if the object has complex relationships, you can get to them. Right? From account, you get to the customer. From a customer, you get to the address. From address, you get to the attribute street.
How about if we have different accounts? Like in this case, we're getting to the same account for the same customer. But like if a customer have multiple accounts and they want to access one of them, how can
we will see that. For now, the association we have established is one-to-one, yes? Yeah. And the idea here, if I have at my hand an account object, can I get to the customer details? Yes. How do I get to the customer details? Account.getCustomer. Now, when I say get customer, I have a customer object. I have all the methods available there for me to call. Yeah. Now, that customer, let's say, has another complex attribute, which is address. I can say get address, and then I get an address object, and I can call the methods there. Yes. Now, if I happen to have a customer at my hand, I have a customer object. Can I get to the account details from the customer? Yes, I can go customer.getAccount. I get the account object, and then from there I can say get balance, get type, get whatever. Yes, that's what association means. Like in this scenario we just saw. The account is aware of the customer, and the customer is aware of the account. And from customer you can get to the account details, and from the account you can get to the customer details. But for the address, I made it one-way relationship. If I have an address, can I get to the customer details? In this case, I judge that it's not necessary. Very rare I will have this scenario. Okay, I don't care. First of all, very unlikely I would have the address as the entry point or the main object, because the main object I have in this whole application, maybe the main object is account. And from account, I can get to the customer, and from customer, I can get to address. So what I mean here, not all associations are necessarily bidirectional. If you wish, you can make it one direction. Is clear here? So the customer is aware of the address. Is the address aware of the customer that is living in that address? No, it's not important in our application. So we're not going to waste time making the address aware of the customer. Is clear? So it's really up to you whether you want to make it bidirectional or unidirectional. Yes? With examples, it will become much clearer. Yes, please. You have a question. Sorry, can you say again? Yes, okay. Here is a customer class. Yes, please. Yep. Down.
Why don't we initialize the method to a public customer and it's already a constructor?
Sorry, why did we?
There is already a constructor of the public customer.
Why we have yet another constructor? Why are we having this extra constructor?
Because we have an extra attribute.
Because for people, this one is for people without address. They say, I can tell you everything except I will never tell you my address. We will tell this customer, no, go away, we will not create an account for you. No, I say, no problem. This information is enough. We can create an account for you. For customers that are nice and they just want to tell us everything about them, if they tell us their address, which constructor I will use? This one. So this is just for extra flexibility. Or the customer might say, oh, by the way, I just arrived, I need an account, so some people will send me some money to survive. Create an account for me. I'll go and use that money to rent, and then I'll call you back and give you the address. And when I call you back and give you the address, which method you will use to set the address?
Second.
There is a set address. No, object is already constructed.
Oh, okay.
So you will use the set address. You will create an address and do set to do it later. You get what I mean? So this is constructor overloading. So we are giving flexibility to the users of our class. You can create the class in various ways. Yeah? Even in here, remember we discussed this before. For account, remember we had before. This is the poor man's account creation. They have zero money. We create an account for them. And this is another one. Somebody came in. They already have some money with them. And we create an account and put some money directly as one operation. Yes? So this is more for flexibility and for making it easier for the users of our class.
Professor, the reason why you wrote super, is it just like
Um,
to clarify?
don't worry about where is this super here. It's the what's the name of it? This one, don't worry about it. This is when I generated the Java like Eclipse put it. Don't worry, that is to do with inheritance. We will cover it later. Don't worry about that one. Yes. I removed it. There is no change. Everything is working as expected. In fact, if I run this, you will see everything is working as expected, and the account is aware of the customer. And because it is aware of a customer, of course, it is aware of the address belonging to the customer. Is clear? Now, in 5 minutes that is left, I want to upgrade now this to make it more realistic. And now, can you see here? Take a look at this. A customer, in reality, they can have multiple accounts. Yeah, in reality, they can have multiple accounts, not just one. Now, if a customer has multiple accounts, guess what? What will happen? Here is my customer, here's account. I have one attribute called account. How can I store multiple accounts in this one object? So I have multiple options. I can create an array and make this an array of customers. An array of accounts. The problem with array, we will discuss this later. I just want to make this one very quick and let you go. The problem with arrays, the arrays are fixed size. If you create an array with 10 elements, you cannot make it at a runtime, you cannot make it 20. It's fixed. So in Java, there is a much better way of having a list of things, or having a sequence of things, or multiple elements of the same type, by creating what is known as a list. So the way you do it, you do a list here. And a list belongs to a package called Java util. I will explain what this means later on. But here, accounts, so how do I make the customer has multiple accounts? By saying the customer has a list of accounts. Now, the attribute, this is not the best attribute. This is not very good. So what I will do here, I will go ahead and say, rename this. By the way, to rename things, I will use refactor. Here, refactor. So it will rename it everywhere. So what will be the better name for account?
Account list?
Accounts, just add S, plural. That's it. This is a better way, okay? Now, in here, this one, now when I say get accounts, it should return what? A list, yes? Here it is. Now, instead of having set, I will not provide set. Let me comment it out. Instead of providing a set, I will provide a method called add account. And what this will have as a parameter, it will have account, and inside what I will do, I'll go to my list. I'll go to my list here and say dot add account, and I will add the account here. So as you create more accounts, I will basically come and add them to the list. Yeah. Now, of course, the list now is not initialized. The list is not initialized. So what I can do, I can either initialize it here by saying new array list. Of course, I will explain what this all this stuff mean. In here, I'm creating basically a list of accounts. That's all I'm doing. Now, in the app here, so instead of doing set account, what I will do, add account. This is Sarah account. And then what I can do here, I can basically do, this is the second account, the number is 234. It belongs to Sarah, and this is current account. and she has there 400. Yes. How do I make Sarah aware of her second account? Sorry, by coming here and say add account 2. Yeah. So now Sarah has how many accounts? 2 accounts. Now, of course, in here I cannot just come and do this because this one is a list. So if I want to do, what I can do here instead, I can have here total. This is the last one. I let you go. I'll add one more method here. One more method. I will call it double. I will call it get total balance. Get total balance. And what this total balance will do?
Add the balance of the first account.
Yes. So it will be double total balance. I initialize it with 0. And then I will loop through the accounts. I will quickly do 4. Here it is, account. In accounts, what I will do here, I will take this one, plus equal, account that gets balance. Yes, once I do this, I will go ahead and return this one. Yeah. So I have this new method here, and I basically can go ahead and call it here, get total balance. That's it. Yeah. So if I run this, I should see the total balance is 5,400. Because basically, Sarah has 2 accounts. One has 5,000 and the other one has 400. So the total is 5,400. So of course, I will go through this in more details, but I just want to highlight to you that for one-to-many relationship, I create that one-to-many relationship by using a list of instances of accounts. And then I can add, you can imagine, I can add accounts, I can remove accounts, and that's what we will be, inshallah, discussing in much more details in the next session. So I hope you are aware now how to create associations, and this is just the start. We will have more examples and more details. Thank you very much.